Hello friends of .NET, I'm Emil Landworth and you can find me on Twitter at TerraJobst. In today's episode we're going to focus on something that we normally leave to our customers, aka testing. So testing has the reputation of being boring, dry and not very interesting. And today I hope I can convince you that there is some fun stuff in testing too, especially because testing compilers is actually one of the things where testing is relatively straightforward. And that same applies to almost anything that does things purely in memory, whether it's your own collection types or whether it's some parsing or diffing or whatever the problem might be. Because normally we have to deal with networking and services and mocking and all the other complicated stuff that fortunately for these kind of things we don't have to do. So we can actually focus on, dare I say, the fun stuff. So the other thing I did last week is I did a poll on Twitter and I asked you guys whether you're up for some music, and it seems that most of you were not really keen on the idea of me playing some Ace of Base, but somebody suggested that maybe I should just perform, and so be careful what you wish for. I've been looking for freedom, I've been looking so long. All that she wants is another baby, she's gone tomorrow boy, all that she wants is another baby. Developers. So next time somebody makes a suggestion, be prepared that I might actually take it. All right, so let me actually switch over to the coding part. Yeah, what the hell, exactly. So let's actually go into the source code. So actually I got another pull request. Let's quickly look over that guy. Yeah, that is true. So where did I mess up my spaces? Interesting. Yep, if you watched my videos, you probably saw that me and Visual Studio Code seem to fight a lot over the indentation. I don't know why that is. I suggest there's some muscle memory problems going on between Visual Studio and VS for Code. I don't know. We will find out. Alrighty, so then we have taken that one. Let me just quickly find my mouse again. Where is it? Here it is. Alright. Let me pull down the changes I just got. So the only other thing that we probably want to do before we go into testing is submit a pull request with our new branch. So if you guys feel like it, you can actually follow along for the ride. So episode 4, testing. That is problematic. What happened here? Oh, I see. Let's call this prep. What? Oh. Nothing like consistent command line syntax. Yeah, let's get this guy. All right, let's push this guy. Actually, before we do that, let's actually put something meaningful in here. Yeah, that directory I think is... I think this directory was here when I played around preparing for the episode. Yep, that's right. All right, so I think the other thing we probably want to do is, because I believe we forgot to add our class library last time. That's right, our solution does not contain the class library. So let's fix that first. No, it's not .NET, it's .NET sln add Minsk CS proj. All right, let's commit that puppy. So, yep, Visual Studio modification. Yep, so let's do this and say add Minsk class library to the project. To the solution. All right, now we have actually a branch that we can push and create a pull request for. Bum, 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 bum. episode 4. All right, stuff is happening. The other thing I would like to do is show you what I mean by testing is fun. So I have this other side project of mine, Inquiry, which is basically very compiler-like. Actually, I might even be able to demo it quickly. That might make it a little bit easier. Inquiry viewer. Yeah, I suspect I might actually launch Visual Studio for that. There's nothing better than some coffee in the morning while waiting for VS to launch. Sometimes I wonder how much coffee Microsoft is contributing to the world, or coffee consumption, by just making Visual Studio start so slowly. Imagine we would speed it up. People would drink less coffee. They might actually destroy an entire industry. All right, so here is my project. So let me just quickly select the startup project. Actually, let's collapse all. Somebody says less than JetBrains with Writer. Oh, with ReSharper, sorry. Well, isn't Writer just ReSharper with Chrome? All right, so come on, Visual Studio, you can do it. I've seen you. I think my machine is actually extraordinarily slow, which is, I think, because of me streaming. So I have this little viewer app here for my side project, and it's effectively, you can write a select query. So you can say select star from employees, you hit a 5, and then booyah, you get your Northwind results back. And so what this thing does is basically just a query engine. So it parses some select stuff. Actually, I can probably zoom in here. Yeah, here we go. It basically parses your query, does some optimization, then runs the query. What's cool with this thing is it's not connected to a database. You can basically throw in anything that is IEnumable, and then you can run queries. And of course, here's a bunch of stuff that I can do, similar to what you are used to Roslyn or ReSharper. You can expand wildcards. You can do small fixes like add an as keyword, and then it will honor that here. You can do stuff like IntelliSense, obviously, first name. Let's do first name plus last name, and then we say country, right? And now you can see where people are from if we would type the query correctly. And now let's say we want to find out how many people come from each country. So we write a little aggregate query. Now you get a bunch of warnings here. You can say, yep, I want this to the group by, and I want, actually no, I don't want that. Actually, I want this to the group by, and run the query then again, and then you get these results, right? So typical stuff. So why is that interesting? Why do I waste my time telling you something that has nothing to do with our compiler project? Well, because once you have stuff like this, it is worthwhile thinking about how you would test that. So for example, I have a bunch of code actions, and I have fixes, I have refactorings. So let's go to a very common refactoring, which is the flip binary operators. So the idea here is, I have a simple one here maybe. Yeah, I guess I have something simple here. So imagine you have a query here, and you have like a first name, some operator, and then something after, right? And so I have my before query, then I have my query that I think is fixed, where basically the left and the right sides are swapped. I have my description for the fixer that I show up, and then basically here's my assert. And what's nice about this thing is that it's a fairly declarative, query or text, I should say. There's not a lot of code going on. So what that means is that my entire unit test for my flip binary operator stuff is like less than 100 lines of code. And if I ever feel like going in and adding some more tests, like, I don't know, let's add what is it? Add as alias. Yes. So here's the thing where if you have a query like this, and the pipe symbol here symbolizes where the caret is in the query. So we assert that in this case, because we already have an as alias, it doesn't trigger. And here we have one where the as keyword is missing, and we are with the caret right after the alias. Then we assert that it's there, and when you run it, that it results in this query. So it's pretty straightforward stuff, right? And we have very much similar tests for the core part. If you go here to actually, is that my tests? Yes, these are my tests. So we have lexer tests, and lexer tests are a little bit more straightforward because there's not a lot of stuff going on. We just have a bunch of asserts, and then the parser tests are simpler. I have basically a bunch of text I want to parse, and then I have my actually assert. And so what I do here is, because with parsing, what you usually want is you want to assert the actual tree structure. And I could probably come up with my own DSL, in text form to represent these. So far, I've not succeeded. It might be worthwhile doing, actually. But I've done something very similar where I basically say, well, let me get an iterator that basically walks over the flattened tree. So we flatten the whole tree into a sequence. And so then you can just assert the individual items here. And what's nice about that is that you can have tokens and nodes, and you can basically have better, here for example, I can also assert that certain diagnostics fire at certain positions. And so that's actually fairly straightforward. And I put the whole bunch into using, so when this guy goes out of scope, then I also assert that there's no, nothing going on, no more tokens left effectively in the input. All right, so let's try to replicate this stuff. Let me close Visual Studio again. So first thing what we need a test project. So let's actually add one. So let's say .NET new xunit output is minsk.tests. And while we're here, might as well say .NET sln add Minsk, so we don't forget that. And now what we probably need here is we need to say .NET add reference to our class library, so we can actually test that guy. And I think at this point we should be able. Well, no. I will launch Visual Studio again. Yeah. .NET build. All right, that seems reasonable. Now we say .NET test for this guy. Perfect. Now let's actually make my life a little bit easier, and let's create a quick batch file that just does both of these things. So we say echo off, and then we say .NET build, and then we say do not build. .NET test, actually, why would I type this again? I just typed it here. By now when I do this, all right, that looks like a reasonable starting point. Add test project. Yes. Sweet. So now we can actually do something. All right, so the first thing I probably want to do is I want to have some lexer tests. So the way I generally like to structure this is that, logically speaking, the tests are a mirror of my other project. So how about we do this? How about we add Do I want to do this? Yeah, I guess I want. So let's do the folder here. Let's say we have a code analysis folder. Code analysis. So the kind of word where there is not much hope for me typing that correctly. So let's just cheat so you don't see me struggling. And then we do a new folder here called syntax. And then I take this guy, move that here. Yep. Do that. And then let's actually fix the namespace as well. Code and what did I just say? Don't want to see me struggle. Syntax. And then while we're at it, we just rename the file to lexer tests. All right, so what do we want to do? So I think for the first thing, we need to do one decision, which is whether we want to do, I wouldn't call it a hack, but it is very often the case that your unit testing project needs access to things that are not public. The key part here is that if you do that, then you're effectively looking into the internals of your class library, which you may not want, right? Because now that means everything that's internal is now exposed to your unit testing library, and you may actually make bad decisions. For now, the nice thing is we don't actually need it. Like most of our stuff already is public. There's a few things that are not public. So specifically when we go to our syntax API here, so we don't need the lexer itself. All we need is a way to lex the tokens. And so we already have a parse method here. So one thing we could be doing is instead of saying parse, we just say parse tokens, and we give back an IEnumerable of syntax token. And then all we have to do is say, yeah, let's create a lexer, and let's say while true, var token equals, yeah, maybe not lexer dot lex, and then we say if token kind is token, no, syntax token, so syntax kind end of file token, then we say break. Otherwise we say, oopsie, otherwise we say yield return token. So why do I not return the end of file token? Because I know that when I want to do this for most parts, I really don't care about the end of file token. Like it's just not useful. For whole documents, sure, but for individual tokens, not so much. So now let's do the following. Let's just say that we want to be able to parse all of our tokens. So one thing we want to do with tokens is we want to think about what it is that we want to actually test. So if you look at the lexer, like one of the things that the lexer does typically is it will make decisions based on characters that appear. And some of the characters it will not actually consume. So when you have one token and one token only, well, that's slightly different from if you have two tokens in sequence. So really what you want to do is you want to make sure that any combination of tokens you can process, and you don't make any bad decisions based on, 3 characters ahead or something. So for example, if you have, a sequence like this, right? You say equals followed by not equals. Well, do you return this as an operator by accident? Like you shouldn't, right? So you expect this to be an equals operator followed by not equals operator. Same way you would expect this to be a double equals operator followed by a pound operator, right? Bang operator. So like we probably want to have a bunch of permutations going on. The nice thing with XUnit is that it allows us to write theories. So I can say theory, and I can say, what do I expect? Well, I want to get a syntax kind, and I want to get it, I guess, yeah, why not? Let's say string text. And then I want to just parse this one token. So let's do that for now. And we say, this is called lexer, lexes token. And so now we need a method, a public static IEnumerable of, let's do a tuple, let's say syntax kind string text get tokens. Actually, let's make this private because we don't need it public. And then we just say return new. Well, what do we have? We have a syntax kind dot. What's happening here? It seems like the problem that I already had, right? Dun, 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 dun. Let's say syntax tree. I suspect I have to quit this guy to get IntelliSense back. So let's do that. All right. Yes, here we go. That makes a lot more sense. All right, now we need that guy. And then we say syntax kind, let's say identifier token A, ABC, and let's leave it at that for now. Unfortunately, in Axiom, you cannot really reference these guys directly. You need an actual public static method that returns an object array here. Get tokens data. And so what I can do is I can just say for each var t in get tokens, I can say yield return new object array with t kind t text. And then what we can say here is we can say member data, name of get tokens data. And now when this unit test run, it will basically call this method and then pass that data into our method. So now there's a few things. We want to assert that we have a single token. And then we want to, pass tokens. And then we want to assert that so what we expect is kind, token kind, and then this is token text, right? Right. So let's make sure that this is actually what's happening. All right, so the key thing here is we have two tests because we have one unit test method, but we pass in two arguments. And this one works. So the reason it works is I can say text plus x, in which case it should fail. Booyah. So you see expected was ax, actual value is a with nothing. It was actually a pretty decent experience, I would argue, for testing this stuff. So as I said earlier, what I really want to test is a little bit more of the variety here. So let's actually go in here and let's think about all the tokens we want to test. Let's copy and paste this guy in here. Let's do this for now. So what do we want to test? We don't want to test bad token or end of file token. These are all reasonable. So let's do this. Dip, 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 dip. Bum, 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 bum. So white space token. What do we expect to be white space? Well, we expect space to be white space. We expect two spaces to be a white space. We obviously expect this guy to be a white space, which is basically CR. We expect line feed to be a space. And of course we expect the pair as well to be a white space token. Where's our identifier? That was here. The false keyword is false, the true keyword is true. Close parenthesis is this. This is open parenthesis, this is the bang equals, this is equals equals, this is pipe pipe, this is ampersand ampersand, this is equals bang slash star minus plus number token. So we would expect 1 to be a number, you would expect 1 to 3 to be a number. So the one thing I would say is we should probably group those guys here together, because the tokens above are all fixed in nature, right? There's only one character sequence that is that particular token, versus these guys here have virtually unlimited characters. So we want to be a bit mindful about those and think about how we would represent these guys. So now let's run this guy again. Booyah, 23. So we just tested that all of those are actually parsable, and they return what we would expect, the right kind and the right text, which is pretty neat, because I would say a pretty high bang for the buck, given that we wrote a single method for this. And it's almost data driven, right? Adding a new token now, I just add a row here and it's pretty clean. As I said, what I really want to do now is I want to create another method that pairs tokens up, because I really want to test that the combination of tokens also parses. So let's call this token pairs. And this is what we say is T1 kind. This would be T1 text. Let me do this again. T2 kind, T2 text. And what I do here is I say for each var T1 in get tokens, for each var T2 in get tokens, I can now say yield return T1 kind, T1 text, T2 kind, T2 text. And let me say same thing here. You just do the translation, get token pairs data, and that is get token pairs. That's the part that's a bit repetitive, and I wish we don't have to do that, but that is the way it is. So this is T1 kind, this is, what am I doing here? Oh, this is T1 kind, T2, T1 text, T2 kind, T2 text. God, I'm an idiot. I am truly an idiot at times. All right. Now we do this again. We say token pairs. And so we say we expect this. We say this is T1 kind, this is T2 kind, and this is T1 text, and this is T2 text. So now what we want to do is we want to say, well, the text is obviously T1 text plus T2 text, right? They're literally next to each other. Now what we want to say is we want to say, actually we expect in this case 2 for tokens. Actually, let's do this, right? 2 array. I probably need the extension method, right? Tokens length. Tokens length. And now what do we expect? Well, we would expect tokens 0 would be T1 kind. That would be T1 kind, this would be T1 text, right? And then the same thing here, we would expect the other token to be like that. Something like that. So let's do that. So this will fail, at least I hope it will. Otherwise, bad things are happening. Yes, so why does this fail? Well, logically, yeah, I think there's another problem that I have where, oh yeah, I pass in the wrong method here. Let's try this again. Why is giving an internal class, no, why is giving a public method to an internal class better than using assembly internals visible to? No, that's not what I meant. But first let me debug this here. So this is, yeah, so this is fine. So the reason this fails, let me first go cover over why this fails. So this fails is because you cannot arbitrarily combine all tokens and expect them to be independently. So for example, if I put the false keyword right after the true keyword right after the false keyword like this, right? This doesn't work, right? Because now we parse a single identifier, right? So there's certain token combinations where you really have to insert something in the middle. So in order for us to decide what that is, let's write another method that deals with that. So we say private static bool requires separator. I think that's true. And we say syntax kind T1 kind, syntax kind T2 kind. And we basically say if T1 kind is syntax kind identifier or T2 kind is syntax kind identifier, then we would definitely say, actually if both of them are, never mind, return true, return false. And then we say here if require separator T1 kind, T2 kind. So if it doesn't require one, then we return this. All right, so this will not work yet. There's more cases here to do more cases. But first, let me answer the question. So somebody asked, why is giving a public method to internal class better than using assembly internals visible to? No, I wouldn't go that far. In fact, most of my tests eventually end up having internals visible too. My point is that if you have a public entry point, it is probably better to have unit tests wired against the public entry point than it is to go via the internal one. Because first of all, it means you're just covering more of your public interface. And then secondly, it also means usually when you design your own stuff, you're more mindful of public APIs than internal APIs. And nothing sucks more when you do a massive refactoring and then you realize that you don't have test coverage for this because, well, in order to get test coverage, you first have to fix up all your unit tests. So it's much nicer if you have a very slim interface between your tests and your subject, so that when you actually evolve your subject, you're not very likely to have to change a ton of test coverage. And so in our case, we already had an API here that parses this thing. I mean, in practice, you also want a parse token method anyway. So me adding that was not a big deal. Like I didn't do this purely for testing. This is a useful method. So that's why I did that. All right, now let's go back here. So there are a few more cases we need to handle. So the first thing we want to do is if either side is a keyword, we want to do the same thing. Unfortunately, T1 is keyword. We can cheat a little bit and we can say T1 kind toString ends with keyword. I mean, massive hack, but hey, works. And these are tests, so it's all fine. Everything is permissible in tests. T1 is keyword, and T2 is keyword. Then it's definitely this. If either one of them is a keyword, the other one is an identifier. So we say T2 kind is syntax kind identifier. Then the same applies. So we say T1 kind equals syntax kind identifier token, and T2 is keyword. Then we also need a separator. What other ones do we have? Well, let's find out. Let's run this. So what fails? White space followed by white space fails. All right, then let's not do that. In fact, let me think about that. I think white space would generally not work. So let's say if T1 is not syntax kind separator white space. Do the same thing here. So we don't want to see any white spaces here. So we say T2 kind. Actually, no. Let's do it the other way around. Let's do it slightly differently. Let's leave this alone for now. And let's remove white space from here. I will test white spaces as well, but this will be differently done. So now when we run this, we should no more have issues due to white spaces. Might have other ones though. So what do we have? We have number token and number token. So that's the same problem, right? We cannot put two number tokens next to each other. That won't work either. So let's say if this is a number token and the second one is a number token, that won't work. So what do we have now? Yep, certain operators fail now. So when we say bang token followed by equals, well, that can't work, right? Because then so if you have a bang token and the second one is an equals token, well then, of course, we expect to return a bang equals token, not two individual tokens. So that won't work. We have equals followed by equals, same argument. So if we have an equals token followed by an equals token, we would expect to return an equals equals token. So that won't work. We have an equals followed by an equals token. Yep, that is a similar argument here, although slightly different. So if you have this sequence here, you expect to return an equals token followed by an equals token, right? In other words, if you have input like this, we would expect to return this, right? Because we eagerly consume the characters here. Like we would not expect to return it like this. All right, so now we're down to 1 and we have equals, so we have, yeah, bang and equals. Same thing there. If we have an equals token, sorry, a bang token, no, what did I copy? I copied this guy here. So bang tokens followed by an equals token. Same argument, if you have something like this, well then we expect it to return like this, right? Because again, we're eagerly consuming that case. Nice. So successful. Now what I want to point out to you is that we have 318 tests. So we basically have a ton of combinatorics tested here. And that's actually a really nice thing with these theories. It's also the downside of the theories. You have to be careful. You can easily create 1,000,000 tests by just having, you know, pairing of 1,000 items. So be careful what you're asking here. So we have this guy here. So now let's actually copy this guy. And let's call this get token or get separators. So white space is, so these are all valid separators, right? These are white spaces. And then I say, when I test my singular case here, my get tokens, I say concat get separators. So now that means I keep testing my, like in the single case, I keep testing that I can parse white space correctly. But in the pairings, I effectively omit them, which is nice. So now we want to also test that if we actually insert spaces, that this also works. So for this, we will create this one here. So now it gets kind of crazy. So we have this one, and then we have syntax kind, separator kind, string separator text, get token pairs with separator. Is this a VS Code bug here, or am I just... I think that's a bug in the VS Code. It probably doesn't like multi-line tuples, apparently. All right. So if this guy requires a separator, then we go over for each var separator in get separators. And then we say as kind as text. Right, so this is basically our remaining stuff. And then we say, we need off here's, where's my, oh yeah. Get token pairs with separator data. Get token pairs with separator. And then we just say this is T separator kind, T separator text. Right. And now we create the actual unit test for that. We say this is get token pairs with separator. data. And then we say, same here, we have syntax kind separator kind, string separator text. And then of course in our case this is now separator text. And then we say this is 3. Right, and then we say this is tokens 2, and then we say this is separator kind separator text. Token pairs with separators. Always it's safe. So we had 323 tests. Now we have 443 tests. Yeah, so somebody's asking what's the difference from writing tests from debugging. Very simple. You invest your unit tests in a different way than debugging, right? So debugging, the idea is you have to do it every single time somebody reports a bug. The nice thing with tests is you invest the time once writing the tests, and then now every single time you change anything in your product, you check it into the CI system, you run the tests. In fact, that's a really good point. Let me go to my build definition on VSTS, which by the way really needs a dark theme. I'm like blinded right now. So if I click on edit here, hopefully it gets me to the pipeline. Yeah, which of course is useless because I'm actually using a YAML file, so I can actually do this here. I don't know why I open another instance of my editor, but here's our Azure Pipelines thing. So we have 2 steps right now. So let's add a third one. Test, and in our case we say tests is, in our case, what did I say? Cat, that guy. So the tests are here, and I use slashes because I'm actually testing on Ubuntu. And slashes also work on Windows, by the way, so that wouldn't be too horrible. So we say, these are my tests. Let's call this, screw it. We repeat the same thing here because why not? In fact, let me do this. Let me add tests to CI runs. So I hope that this now means that it picks up the, I'm not sure it picks up the YAML file from the branch it's building, or whether it only picks it up from master. So that will be something we will see soon. Oh, actually it says pending test, so that's great. So it will actually pick up the YAML changes from our CI branch. That's pretty neat. Didn't know that. Well, I mean, bugs will always happen, right? No matter how much test coverage you have, bugs are happening. But I mean, there's this question of like why have tests in the first place? And one of the most important classes I took at university was done by an engineer from BMW who talked about testing. And I think the most, I think, memorable line from him was, you test because you have risk. If you don't have risk, there's no point in testing. And I think that's very true, because if you just write a website where the worst that can happen is it looks crappy and the website is used by 3 people, don't spend a lot of energy of unit testing your website. It's just not worth it. If you write a compiler where every part of your language can interact with any other part in the language, trying to reason about this in your head, they're not going to fly. And so if your language ends up being used by a bunch of people, you don't want to break them all the time. And so that's why, recently there was a tweet exchange between different teams of who has more unit tests. And when I remember correctly, I think Rosen has 400,000 tests. And of course they are similar to mine in the sense that some of them are theories, and some of them I think are inflated from the fact that they run on different build configurations and all of that. But it gives you an idea of like what industry strength test runs can look like. So just because you can have bugs shouldn't mean you shouldn't have tests, because, well, then you just have more bugs. Like, that's just the way it is. All right, so now our tests are passing here, I think. So what did I want to do? So I have like all these guys now. I think we're now at the point where we can actually start to commit the rest here as well. So let's just say these are our lexer tests. Let me guess, I have a UTF-8 with bomb. Why? Why do I have a UTF-8 with bomb? Safe with encoding, UTF-8. Who wants a bomb? Yeah, that looks much nicer. So here's our lexer. Yep, this one is gone now because that's an empty unit test. Actually, now that I'm thinking about it, I probably want to first commit this guy here. And we say expose syntax tree dot parse tokens. This method can be useful generally, for example, to validate that a given text is a valid identifier. All right. And then we add this and we call this. Now this is a bug I have to fix. This is annoying because I have to do this. All right. Let's call this add lexer tests. All right, let's push this. .NET test succeeded. So now my test will run as part of my CI, which is exactly what we talked about earlier. All right, now we have our lexer tests. Now let's talk about our parser tests. Well, for starters, we don't have any, so let's create a type for that at least. Let's call this parser tests. Now that I'm thinking about it, yes, I want that. Git, what are you talking about? Git rm. Really? This is amazing. Git reset. What's happening here? Why? I see what's happening. I've modified and I have, okay, so now it's actually what I want. So now it says, yeah, modified to end new file. Great. All right. Git move. Now git commit. Rename. No, actually that does not sound like right. Why we have both of them? So we have lexer tests, that's the word. Okay, so then let's do this. Delete. Why the heck? Yeah, permanently. I don't make mistakes, as we just saw. Alright. Gee, renaming a file. We have set a new bar for things that can throw me off. Git reset. No, what do we have here? Yeah, that makes more sense. Now we say lexer tests. Git add. Oh, for fuck's sake. Really? Really? You make me type this now? Yay! Yes, that is what I expected. Rename lexer test to lexer tests. Congratulations, you renamed the file. It only took you 10 minutes. Ready to get promoted. All right, so we now have a new method here, public void parser binary expression honors precedences. So let's start with theory. And let's say what we want is we want a syntax kind yes op1 syntax kind op2. So basically one of the things that we want to make sure with our parser is that when we parse binary expressions we get the correct trees. Yeah, so somebody's asking why I'm using snake casing, meaning underscores. I just like them to be more readable. I probably should also fix my XUnit configuration so that the test name is not namespace, type name, method name, because I actually like that more. And this way I basically have a nice grouping of the area and then the sub area and then usually it's some condition that I have here that I want to make sure. So this way if I want to search for all the tests for binary expressions, I just enter binary expression and then these things pop out, or all the parser tests, I just search for those. I don't know, I don't find namespace qualified names for unit test names super readable. I mean, to be honest, the unit test output is not super readable on the command line. I've ranted about this on Twitter as well. Hopefully we'll fix this at some point, but there's no reason why the source code should be looking super messy. So how do we want to do this? So the first thing I want to do probably, because honestly, we already have a syntax facts method. And really what I want to do here is I want to add, I already have this mapping from keyword. Yeah, basically what I wanted, I want a method. Let me actually just explain what I want and then it may become obvious. Syntax kind, no, sorry, string get text for syntax kind. So very often, most of the operators, as I said, if you go back here to, where is it? Lexer tests. Many of my operators actually have a fixed text. So let's just do this. Yeah, except for here. And then let's do this, and let's call this, oh God. All right, so now yeah, it would have helped if I would have prefixed it with case. And actually it probably would have helped if I had a switch statement to begin with. Really? Really? All right. And then we say default cases we don't know, so we say default return null, which is basically our placeholder for we do not have a fixed text for this token. Now before we go any further, let me create a different test for that. Public class syntax fact tests. And I probably at this point regretting what I said earlier, because I'm not sure I want to make this guy public. Or, you know what? Why not? Public. This is actually not a bad thing to have public. So we say public void syntax fact get text round trips. Values, let's just say enum. Actually, let's move this guy into the correct type first. So sometimes when I write tests, I realize I want to do something differently, and then I'm getting distracted for a while. Get values. Let me guess. You need a using for the system namespace, and then I think, yeah, we want to get type of syntax kind, and then I can cast the result to this. All right, now we say for each var value in. No, actually, let's make this a theory, and this makes a lot more sense. Theory syntax kind, and then we say public static enumerable of object array syntax kind get syntax kind data, and we say for each var v in, actually let's do this, kinds for each kind in kinds yield return new kind. Yeah, I guess that is fair. All right. So now we have that, and then we can now say text is syntax facts get text for kind. I can say if text equals null, return. Otherwise, I can say var token is syntax tree parse tokens for the text. Var token is assert single tokens, and then we say assert equal expected is kind token kind. And of course, we expect the token text to match the text. Oh, it doesn't compile. That is sad. Why is it not compiling? Theory attribute. What's going on here? Parser tests. Oh, the parser tests don't compile. Yeah, who cares? Yep, it's. Gee. The X-unit analyzer is actually pretty good. It's like your theories are all wrong. Actually, yeah, and this one is also wrong because it needs member data, name of, get syntax, kind data. Open parenthesis token, actually close parenthesis token. What happened there? Did we mess it up? Syntax facts, where is it? Yep, we messed that one up. Must have been when I fixed it up in Sublime, because I think here it's actually correct. Open, close, yeah. Nice. All right, so let's commit this by puppy here. So we have, we don't want to commit this. So we have our syntax facts here. We have this guy here. And then we say get text. All right, so now we can say make syntax facts public and expose syntax facts get text. So why did I just spend my time doing all of that? Well, because now I can say member data get binary operator pairs data. Let's actually write a method like that. I say private IEnumerable static IEnumerable numerable of syntax kind. I say get binary operators. Thinking about this logically belongs here. We can make this public. And we can do the exact same trick we did earlier in our test here. So we say we have this guy. And then we can say for each var kind in kinds, and then we can say if get binary operator precedence for the kind is bigger than 0, then we say yield return kind. And while we're at it, get unary operator, I guess operator kinds, get binary operator kinds. We can do the same thing and say get unary get unary precedence. Because remember when we did the precedences, we said if we return 0, it means it's not a unary operator. right? So now I can say public static I enumerable of object array this guy, and then all I have to do is I can say for each var op1 in syntax facts get binary operator kinds. Yep, and then we do the same thing again. op2, and then we say yield return new op1 op2. So we have all pairings of binary operators. And what's your problem? Yeah. Object. Fair enough. How about this? All right, before we do that, we should probably add a test case here that they also work. And we should say get binary operator. Actually, who cares for now? Let's not do that. So now let's just say if syntax facts get binary operator precedence op1. So let's say this is var op1 precedence op2 precedence. So what we now want to do, let's also do op1 text is syntax facts get text for op1 for op2, and then we say var text equals a op1 text, b op2 text, c. So now we want to say if op1 precedence is larger than or equal to op2 precedence, then we want to ensure that our tree looks like this, right? We have a op1. I guess let's do this. Let's make it pretty while we're at it, because pretty is the least readable. op2. Right, that's the first case, and then the other case is this one here, right? Right? So in other words, you want to assert that this is how the trees look like. The problem that we now have is that we don't have a convenient way to do that. So I think we need to write us some code that can do that. Let's first make sure we actually assert false. We actually fail. Yeah, we have 64 tests that fail, which sounds about right for operator pairings. So one thing with theories you want to be careful is that you want to make sure you return non-empty result sets, otherwise bad things will happen. So how will we do that? So basically, let's have an internal sealed class asserting enumerator. So what do we want to assert here? So the idea is I pass in a syntax node, then I have a private enumerable syntax node flatten method, static, and given a node flattens the tree. So basically what we say is var stack equals new stack syntax node, we say stack push our node, and then we say while stack count is there, we say var n equals stack dot pop, and then we say for each var child in n get children reverse, because it's a stack after all. We say n dot push, no, stack dot push child. Yeah, and here we say yield return n. Does that seem right? I think that seems right. Now we say private enumerator of syntax node let's just say call him enumerator. And then we just say this guy is flatten for node get enumerator. Right, and now all we have to do, we have to say public void assert token syntax kind string text equals text, and then we can say, well, first of all we say assert true for enumerator move next, then we say assert, well, I guess it is true, no, this works, right? Yeah, equal enumerator current, I guess it's this, right? I can never remember. Expected actually, yes. Kind. And then we say text equals text. Yes. Yes. So var token assert is type syntax token enumerator current. So we basically say, okay, this guy, I expect this to be of type token, and then I can say that makes a lot more sense actually. Now we can do that. So what we also want to do is you want to implement idisposable, because idisposable Yep. Because first of all, we want to dispose the enumerator. Not that that matters probably for our cases, but nonetheless, cleanup is generally a good thing. And then more importantly, we want to make sure that we say assert false enumerator move next. Right? We expect this to be at the end of the stream, so to speak. Let's add another method, assert node. just with a kind. And generally speaking, in that case, we say we don't expect this to be a token then. And now we say just enumerator kind. Current kind. Right? Because if we're saying it's a node, it better be not a token. I mean, token is derived from node. That's why we do that thing here. All right, so now how would this look like? So we would say var using var enumerator, let's call this E, is asserting enumerator for our, oh yeah, we need an actual expression here. Var expression equals syntax tree dot parse for our text and the root. So we now want to have an asserting iterator for this guy. Oh yeah, and this guy needs a new. So we say E assert node. I even know at the top here. We say assert node for syntax kind binary expression. Then we walk the left-hand side first. Yeah, which we do. Then we work the left-hand side first, so we expect this to be a name expression. And then we expect this to be a token for identifier token with the text. Then we expect to do the same thing for the other side, B. And then we expect this to work for this side, C. So we want to indent this to make it maybe a little bit easier to read. It will look like this. I hope this kind of makes sense. So let's think about how this would look like. So we have all the same nodes. Actually, let me copy the whole thing. We have all these nodes here. We just have to arrange them slightly differently. So we start with a binary expression. Then we walk the left-hand side, so it's a name expression, an identifier. Then we walk the right-hand side, which is a binary expression. Then we walk the left-hand side, which is B. Then we walk the right-hand side, which is this one. And honestly, the indentation does not make it easier to read, in my opinion. All right, let's see what this does when I actually run it. Yeah, so here's one problem that we have with this idea. So here's the fun part. So if any of the assert methods currently throw, what will happen? Well, they throw here, let's say. Then we go up the chain. So now we dispose the asserting enumerator. Well, what does dispose do? Well, it asserts false on the move next. So really what we want to do is we want to make sure that private bool has errors. That we only do this if we don't already have an error. Otherwise, what we do here is we throw again while the exception is propagating, thus effectively replacing the current exception, which is not what we want. So one easy way to do this is to do this. Try, put all of the stuff. Really? I thought there was a template for this. Yeah, there is one. Is to do this. Exception, and then say has errors. In fact, we don't even care about this one. And we just say has errors is true. What are you talking about? Oh, we needed a brace. That's what's going on. All right, that makes more sense. And then we do the same thing here. So the only thing is, we can actually do something slightly cleaner, which is a neat little trick. So right now what we do is we actually catch the exception and we throw it again. We can also do something slightly more funny. We can say private bool mark failed, and then we can say has errors is true, return false. And so what we can now do is we can say, instead of doing this, we can say catch if, what was it, when mark failed. Which no means we're actually never catching the exception, but as a side effect, we mark that an exception occurred, which is quite neat. So now let's go here, let's say build again. So now we still might have errors, because our assert methods were throwing in the first place, but now we actually have the original ones. Actually, no, we don't. Did I mess that up? Oh, yeah, I need to fix the condition here. And now we see the actual errors. See, now we no longer get the dispose error. Now we get the actual errors. And apparently a lot of them. Really? That many? That seems hard to believe. Well, I guess it makes sense because okay, so in order for us to make our debugging easier, because the console output is so horrible, how about we just return one pair and then we say yield break. This is where we only have a single error to deal with. And then we can take it from there. All right, we have a plus token followed by a plus token. Assert is not failure, syntax token. Expected type of syntax token. Actual type of syntax token. What? All right, assert node is not of type syntax token. That makes no sense to me. So where does it fail? Line 53. Wow, line 106, that's the actual one. So we're here, we're saying name expression. Oh yeah, I'm an idiot. So probably, in order for us to make this not quite as bad, we should probably assert the kind before we assert the types. And the reason for that is so that when we mess up the kind, we fail with a slightly better error message. So, because I'm actually not standing on the right thing. So I basically forgot the operators, right? So the operators are tokens that occur when you flatten the tree. So let's do that. Now it says we expected the name expression, but we actually found the plus token. And that's a much, much more actionable error message, because now we just have to figure out where the guy goes. So it is clearly, so this is clearly the, what is this, the OP1, and then this is OP text, and we have the same thing for OP2. So now the question is, where does our, so we have to plant them down here as well, so let's not forget that. So we put this guy here. So we have a name expression, then we go down the left hand side, which is a name expression, and then so this is where the first operator would go, and then this is where the second operator would go. So same here, so we go down, so this is the first one, then we go down this side, so this is where the first operator goes, binary expression, and then this is where the, no, this is where the second operator goes. Yep. That's exactly right, Rich. Sometimes you have this great idea that you do the right things and then you don't do the right things. So now we have 470 tests. That's pretty neat. And now we're actually asserting that our operator precedences are parsed correctly. So let's first move this guy into its own file. And that's actually pretty neat. So let's add this as a commit in its own. So this is our asserting enumerator. This is our let's do this first. Sometimes I change my mind in the order in which I commit. So what I want to commit first is add syntax facts get binary operator kinds, and then while we add it, all right, and now we can say whoa, that's a bug we should fix. Git commit. What is it? Assert add test to verify binary operator precedences are honored, let's say. Rich has a good point. Or I should say Richard. I'm not sure you want to be called Rich. I should probably remove that one here. So let's do that. And let's just amend our previous commit. Nobody saw that. Which is probably now, actually, now that I'm thinking about it, probably should have run it before. Because what are the chances that the tests are just passing? Oh my god, they did! And yes, now we actually have a lot more tests. Yeah, let me guess, the red comes from the fact that I force pushed this guy over. So this guy passed. So I'm curious to see, do the tests show up here? Yeah, that's what I thought, because we just run it as part of the script. So we did run the tests. It's just that the CI doesn't see them. To think about how we promote this in the CI, probably I don't think that's quite the right way to run them, but hey, good enough sometimes is good enough. All right, now that we have the binary ones, we probably want to do the same thing with the unary ones. So in other words, we have the same problem with unary followed by a binary. So let me just copy and paste this guy. Let's call this unary expression. And so logically what we want, so we have just A and B. So what we want to assert here is this. So there's one way to parse it. This is actually the second way. The other way would be so if the unary binds stronger than the binary, maybe we should say unary kind, binary kind, and we can say unary precedence, binary precedence, and then we can call this guy unary. No, actually, this is the binary, and then this is the unary. And then same thing here, we call this binary, and we call this unary, right? So the unary binds stronger or equal to the binary, then we first do this one, otherwise we do the other one. And of course this is get unary precedence, get binary precedence, and we call this get unary operator pairs. Which now means we say, probably should have copied that name, and then we say this is get unary operator kinds, and then get binary operator kinds, so we call this unary and binary, just for consistency. Call this unary text, binary text. All right, so what do we expect? We expect first to get the binary, then we would expect to get the unary. The unary first has the token, then the expression. Then we would expect to get the binary operator, and then we get our B. So now we would expect to get the unary first. So we say this is the unary expression, then the unary operator, then we would get the binary expression, and then we would get the name, get the binary token, and then we would get B. That does look right. Let's see what the test says. I probably have to again do a yield break, which hopefully I don't forget to remove this time. Oh my god, it just passed. There's no way this just passed. If I don't get them to fail, then maybe I did something wrong here. Okay, that makes me a lot happier. All right. Let's call this add tests to ensure we honor unary and binary precedences. All right, I think from parsing this is actually pretty decent. There's more that we should do. We should make sure that we can parse every single construct, but I really want to do some evaluation as well. So how about we leave parsing alone for a moment, and we add a new file here, and we call this evaluator tests. And because I'm really lazy, and we call this evaluation, I guess is a better way to do it. Because I think now it's actually called evaluate. I guess it's evaluation test is fine. So what do we want to test? So I think here are some of these things where we probably can just get away with inline data, where we basically parse in the expression 1 and the value we expect is 1. Right, so we would say string expression object value, and then we would say var expression, I guess that's we should do text, expression is syntax tree.parse the text, var compilation equals new compilation, of what? The expression. Let's call this syntax tree. What's wrong here? Oh, predefined. And then we say var actual result equals compilation evaluate. We say variables equals new dictionary string comma object. We probably want some default here so we can actually have something to work with. -4. And then we can say variables. Now what do we get back? Oh, variable symbol. I see. Well then we are kind of screwed here because we cannot actually create any variables yet. Then we do it like this, and we say extra result is this. Probably good enough for now. can always cheat. Actual result, and then we just say, what is this? This is value, actual result. Okay, let's say expected result. Result, and then we can say assert. We should assert that we don't have any diagnostics, and then we say, yeah, let's call this expected value. Right, that seems fine. So now we can say, well, we expect this to work. So this is our unary expression. We would expect these to work. We would expect this to work. This would be 3. What else do we have? Plus, minus, multiplication, division. We would expect parenthesized things to work. So let's say 9 divided by 3 is 3. We would expect 4 times 2 to be 8. We would expect that to be minus 1. Let's actually have a little bit more interesting numbers here. So this would be minus 3 would be 9. And then 14 plus 12 is 26. So now we have unary, binary, parenthesized. Now let's do true. False. We would expect not true to be false and not true, not false to be true. Let's see what ends up happening. Nice. So we now have tested, I think, if we go to our evaluation method here, if we go to evaluate, so we have tested literals, we have not tested variables or assignments, we have tested unary, we have tested all 3 of them, we have tested binaries, plus, minus, oh, we have not tested and or, and we have not tested equals. So we should do that. So let's say 12 is, we expect this to be false. We would expect this to be true. Let's test not equals as well. So that would be true. That would be false. True is true is true. So false is false is true. True equals false is false. And let's do the reverse of those. So what helps in these kind of cases is if you just systematically try to enumerate the cases, so that you, and I try to avoid special things like here. So for example, true equals true. I don't want this, because if you have a bug where you just return the first argument or something, that looks weird. So that's why I try to vary it a little bit to make it slightly harder for me to just have dumb bugs that accidentally test as correct. So what else? So I think we want variables. So let's say a equals 10 times 2, that would be 20. Well, times a, that would be 100. Yeah, that's the only way we can test expressions right now. So let's say we make a mistake here. Let's actually make sure that these tests are actually running. Yes, so we expected, so we said a equals 10 times a. We expected 90, but it's actually 100. So that means they are all running. And now we have test coverage for what I would consider the riskiest parts of our compiler. So the precedences in the parser, the combinatorics in the lexer, where we miss certain things. And then, again, like this is for some reason with a bomb, which I don't want. So let's do this. Add evaluation tests. So have we tested everything? No, we have not. Have I done code coverage analysis? No, I have not. I probably should. Not so much because I care about the actual number that comes out, but with code coverage, one thing you can easily do, you can effectively, what I did here by hand, seeing which cases you haven't covered, right? And so you just go to the areas that you want to make sure you cover them all, and then just check that you actually did. And then if you have some code paths that are not covered, which you expect to see covered, you can just fix that there. So I think that is pretty much all that I wanted to achieve today. Plus I'm out of time. My girlfriend has to go to the airport. So if I go over time today, I'm in deep, deep trouble. Even more so as if the tests wouldn't pass. All right, so that brings us to, I think, the summary of today. So we did tests. I think now when we actually have dumb errors, hopefully we can find them. There's more stuff in the structure that I want to add. For example, the evaluator right now uses is checks. I really want to move them to a switch statement. I haven't done that, but we can totally do this next time when we actually have tests to verify our refactorings. So if you have any questions, please comment on the video, comment on the PR, and then hopefully I see you guys next week. Bye-bye.